All right, so this is actually the last section in Chapter 5. Trapezoid rule is it's an approximation. We're going to use this instead of, say, the fundamental theorem of calculus on problems where we look at it and the antiderivative is something we have no idea how to do it. Because let's face it, yeah, the fundamental theorem of calculus is great if you get something like this from A to B and that function that's sitting there, you know how to take the antiderivative. But if you don't, the fundamental theorem of calculus is not helpful at all. Right? And so, well, what do we do if we don't have that? We have actually two approximations we can use. One of them is trapezoid rule, and let's face it, that's one of the things you said we could put underneath that curve earlier in this chapter. When we looked at some of them, well, a trapezoid would be pretty good. And then I kind of shot it down saying, well, that could be a lot of trapezoids, there could be problems, and there would be. But if you can't do the antiderivative, that's the way you have to do it. Okay? Keep in mind that when we did the Riemann sums, or the sigma notation and all those things, we used rectangles. And why was that again, that we used rectangles instead of trapezoids? Why would we choose that if trapezoids are more accurate? Yeah, it's just base times height. The formula is way easier than this one. Does anybody happen to remember the formula for a trapezoid? Yeah. Okay. Close. It's base 1 plus base 2 times height divided by 2. Now, why is that again? Why is that actually the trapezoid rule? Or the trapezoid formula? Anybody remember? As if I were to take another trapezoid and slide it in there, it's a parallelogram, which is base times height, correct? But to get this entire base, what do I have to do? Add base 1 and base 2. That's what they have there. Pick it times the height, but then I don't have all of that. I only have half of it. And that's why that formula works quite well. Okay? So that's the formula we are going to take a look at today. So again, you notice what's here. This is not a typo. Approximately equal to. Now this again looks a lot like the fundamental theorem of calculus, but again, we're only going to use this. Now I'm going to be nice. I'm going to give it to you on ones we can actually do it to see how close it is. Okay? I will show to you, because right now this looks like a bunch of gibberish. Okay? So what we're going to do is we're going to do a couple by hand and see if you can kind of figure out, well, why are there like 2's kind of floating around on some of them, and there's a b minus a in there, there's a n, a 2, what's going on in there? Hopefully by the time we do a couple by hand, you'll be like, oh, well, I can kind of see where that would come from. Okay? I'm guessing right now you don't. The other approximation that we're actually not going to do in here is called the Simpson's rule, where basically what they do is they throw a bunch of parabolas in there, which is rather interesting and quite a bit more complicated. So use the trapezoid rule to approximate that one. Okay? Why don't we take just a break real quick just to review the fundamental theorem of calculus. Why don't you go ahead and actually let's find out what this answer is supposed to be. But if I were you, I'd say like, maybe put that work like over there. Don't put it in the trapezoid rule area, because then you're going to think that's the trapezoid rule. Right? Say we're just trying to get the actual answer off to the side to find out what it is so we can find out how close we are. And those listening to the recording, please actually do that, because I'm going to pause it. All right, hopefully that was enough time. Again, if you are listening to it, please actually try this. You're going to learn a whole lot more. So 0 to 3, well, I have it written right there. I don't really need to write it again. Antiderivative is x to the third over 3 plus x, which we would go from 0 to 3. You put 3 in and you get, what, 9 plus 3, and then we put 0 and you get nothing, right? So minus 0. And so the correct answer is actually 12. That's not approximate. That just is the answer, correct? So what we're going to do now is let's just get a little sketch of this as to what it is, and I think I have one in there somewhere. It's right there, because it is a parabola moved up 1 that opens up. And so it'd be 0, 1, 1, 2, 2, 5, what, 3, 10. Okay. And this particular one wants us to use 3 trapezoids. So this is very similar to like when we use the right rectangular approximation method and the left one. Okay, but this one should be much more accurate than those. Okay. And so go ahead and put your trapezoids in there. You can kind of see mine now. I basically just went to 1 and I went up to the graph right here. And then I just went back to that value there. And as you can see, that is a trapezoid. Hopefully you can see how in some examples it might actually, instead of making a trapezoid, it might actually make a triangle on some of them, right? But that just means one of the bases is 0, right? And then this one I just went up, down, across, down. So we have basically 3 of them. Now, how would I decide how wide each one should be? How come I just went to 1, 2, and 3? I just felt like making that up, or what? How would you figure that out? It says from 0 to 3, and then I wanted 3, right? So basically you did 3 minus 0 over 3, otherwise known as b minus a over n. Isn't that what we did with rectangles, right? Now, did we see that in the formula earlier on the page? We did. But what else was on that darn thing? There was a 2. We're going to have to figure out where that thing came from. Yeah, we're going to have to figure that out. All right. So we've got these over here. I'm going to number them. 1, 2, 3. Let's draw them out over here. Here is trapezoid number 1. Now remember, the bases are the ones that are parallel, so that would be these 2, correct? You with me on that? I totally missed when I did it, but these are the 2 that are parallel. So then this is your height, right? So what's the height on this thing? Really, it's 1. Everybody see that? Everybody okay with that? You're kind of staring, so I'm not sure. Okay. So then how about this one on the left-hand side? How tall is that? Well, it's whatever that is. So it's ever when I put in 0, right? It'll be whatever that distance was. So if I put 0 in here, I find out that this is 1. What's the other one? Well, that would be the one over here. So that's whatever I get when I put in 1. Everybody with me on that? So how much is that base? 2, right? Do I need to find this one up here, this top one, to find the area of that trapezoid? No, because here's your right angles, right, to find the height, so I don't have to. So if we did base 1, 1 plus 2 times a height of 1, all divided by 2, correct? Would be how I would find the area of that one. So what are we looking at? 3 over 2? Well, that's not 12. Well, that's not a very good approximation. Oh, we got to do the other ones. Oh, silly me. All right. So let's do the second one in red. We'll kind of color code things, at least I will, so that maybe it's easier for you to take the notes. So here's the second one. Here's your right angles again. Here are your bases. So sometimes you got to turn your head and be like, oh, our bases are normally on top and bottom, but they don't have to be here. Well, once again, how tall is this one? This one right here, how tall? Really, that's the height, right, of this trapezoid? Is once again 1, correct? How about this one here? That particular side. Wait a minute. I just did that one. Didn't I? Are we with me on that? Isn't that 2? So now I got to go and get that one. So in other words, it's whatever I get when I plug in 2, right? So 2 squared is 4 plus 2, so 5. Everybody clear with where these numbers are coming from? This 2 on the inside is just me notating that's the second trapezoid. Don't think that happens to be the height or anything like that. So if I do this one, we do 2 plus 5. That's base 1 plus base 2 times a height of 1, all divided by 2. And so that one is 7 over 2. And the last one I will do perhaps in black. Is that one? So you can see the more trapezoids, kind of like the more rectangles. Ooh, that was actually pretty good. The more trapezoid we do, the more of a pain this is going to be, right? So this is 1. How about the one on the left of this trapezoid? Oh, we just did that one. Oh, that's interesting. How about this one at the very end? Have we done that one yet? What is that last one? We'll put 3 in. What is it? 10. Again, this is just the trapezoid number. So 5 plus 10 times 1 divided by 2 is 15 halves. So basically what we've got here, we'll do it in blue, we have 3 halves plus 7 halves plus 15 halves. Well, luckily enough, we have a common denominator, right? Well, that's kind of nice. What do we have? 25 halves, which is 12.5. So was this approximation actually pretty good? Was it too high or too low? Now, do you notice that this graph is concave up? Correct? Concave smiley face, I think is what some of you call it, right? But concave up. And of course, we would do the second derivative of that to find concavity if we had to. But it is concave up. And if you have something that's concave up the whole time, trapezoid rule is going to give you an overestimate. If it's concave down, it's going to give you an underestimate. Okay? Yeah, very good. Concave up is going to be an overestimate. Okay. So now, based on this, does that formula we saw on the other side, any idea where anything's coming from? There's a 2. Where's a 2? Underneath all of them. That comes from what? The half in the formula, correct? So far, of this formula, have we somewhat... We know where the b minus a over in comes from, correct? That's always the height. Where's the 2 coming from? From the half. So does that happen every single time? Was our height always the same? It was always 1. Did we always take a half in this one? We did. Now does that mean the height's going to be 1 every time? No, I mean it could change depending on the problem. But that 2 is out there because that is the 1/2. Well, then what are all of these numbers? They're just f with some value put in. So these are just y values. Did we deal with any y values in the problem we just did? Any y values back in this problem? Yeah, aren't all of these just y values? Look at the very first y value we used. How many times did we use it? Once. Look at the last one. How many times did we use it? Look at the ones in the middle. How many times did we use them? Twice. Because they happen in how many trapezoids? 2. So that's why if you look back at the formula, they basically say for the very first one, how many times am I going to use it? Once. For the next one, I'm going to use it twice. And it basically says keep going. And then it should say plus like an ellipsis in here. And then the very last one you're going to use just once. Again, there should be an ellipsis there if there isn't on yours. Okay. So why don't we just do this last one by hand, and then we'll see if the formula actually still works as well. So let's do trapezoid rule for 4 minus x squared. You're probably going to get pretty sick of that. In fact, we did that one the other day, I believe. And we got the answer to be, the actual answer is 3, if you wanted to write that off to the side. So let's find out if we did the fundamental theorem. And so this is one. Graph looks like that, right? Yeah, this is the one some of you may have graphed wrong the other day. So it's what, 0, 4, 1, 3, 2, 0, and then 3, negative 5, I believe. And this is where we kind of struggled even drawing in what are we finding, right? So see if you can draw in your trapezoids when you're done as well. Yeah, so this one actually ends up not having all trapezoids, right? It does have a couple triangles, but that just means one of the bases is 0. If you didn't notice that, it really is then the same formula for a triangle area if you just make one of the bases 0. Why don't we do this one by hand? Or do you want to just try and use the trapezoid rule, or by hand and then trapezoid rule, or what would you prefer? It's up to you. Do it by hand, but then I will show you how trapezoid rule actually does work. So the first trapezoid right here, number 1. We'll draw it over here. So once again, how would we figure out how wide it is? Well, it's b minus a over n, which is 3 minus 0 over 3. So once again, I was very nice to myself on the problem I made myself do on the board. I made the height of every single one of these 1, correct? So this is 1. How about this left-hand side of that trapezoid? I believe that's 4, correct? And then the right-hand side I would figure out by putting in the right-hand side of that trapezoid, which happens to be right here, correct? At 1. So if I put 1 in there, I find out that we get 3. So once again, there's these y values coming in again, right? So if we use the formula, it would be 4 plus 3, which is base 1 plus base 2 times a height, divided by 2, otherwise known as 7/2. Number 2 is actually, well, it's better than that, but it is a triangle that's base of 1. This height I just used of 3. What's the height on this side? 0. So can we still use the trapezoid formula? We can. 3 plus 0 times 1 divided by 2. In other words, a triangle. Right? So let's maybe write our numbers here. We got 7/2. We're going to add on now 3/2, right? Now the third one. Perhaps we'll do a different color. 1, 0 for this side. Careful. The right side, meaning that right there. Put in 3, we get -5. So it's 0 plus a -5 times 1 divided by 2. Again, the divide by 2 is from the formula, right? 1/2 base 1 plus base 2 times height. So it's -5/2. Otherwise, it comes out to be 10 minus 5 is 5/2, which is 2.5. What was the actual answer? 3. So pretty good. So what I'm going to do now, because we are kind of running out of time here, I am going to actually erase this and show you how you could actually just use the formula. Okay? But I'm going to show you the most common pitfalls of the formula as well. So out front of the formula says to take b minus a all over 2n, correct? That's what it says out front on the other side of your paper. That's because b minus a over n is your height every time, correct? And the 1/2 comes from the formula. Everybody with me on that? I'm going to show you the most common pitfall. So that's fine that we do 3 minus 0, right? Over, I'll just do it 2 times 3, right? So what would really be out front is 3 over 6, otherwise known as 1/2, right? Is out front, and I'm going to show you where that is on the formula in a second. Okay, so there's that's basically this part, right? So now what they do is they just start plugging in the appropriate y values, right? So let's do that. So now, be very careful. The very first y value is right here at 0. That's quite easy to do, correct? And the first y value is 4. How many times am I actually going to use that? Just once, correct? Plus 2 times whatever the next y value is. Okay, here's what people do. They say, oh, the next y value is 1/2 away. It's 1/2 over. Is that where the next y value is? No, because they just think this number out front is how much they have to go over by every time. It's close, but remember, what did we throw in there extra? The 2, right? We threw in that, we factored that out as well. Okay? So maybe just move over 1. So if I move over to 1, well, what's the y value on that one? It is 3. And why is there a 2 there in front of it then? Because I use it twice. Plus. How many times do I use that next y value? Twice, because it's not the final one, right? But let's face it, this one is 2 times 0. I'm running out of room, I apologize. Plus I wonder if I can just move the whole thing. Think I can? No. Yes. Plus. So we're down to, so we've done this one, we've done that one, we've done basically that one. How many times am I going to use this last one? Once. So plus, really unfortunately a -5, right? Wait a minute, how come there's 1, 2, 3, 4 numbers here when I only wanted 3 trapezoids? Yeah. Okay, you can kind of look at that. Well, that's normally why I write them all out. Somebody just said because one of them is 0, but that's not always going to happen. Well, let's put it this way. If they ask for 3 trapezoids, you better have 4 separate things here. If they ask for 6 trapezoids, how many things should you have here? 7, right? Yeah, you got both sides. You got to keep that in mind. You got to finish, right? Or if there's 20 trapezoids, you better have 21 things here. And if we do the math on this, we get That's what I'm saying. That's why they made this, so that you didn't have to go in there and do all the trapezoids every time. They said, hey, wait a minute. We got this thing happening every time. Whoops, I did that wrong. We got that thing happen. Well, that just looks like a really bad picture. Okay. They're saying we got this thing happening every time, right? B minus A over N. We got this 1/2 happening every time. So what did they do with the stuff that's happening every time? They factored it out. That's all they did. They factored it out and threw it out front. Do these change depending on the problem? Yes. But this one happens once. These all happen twice. That one happens once. Okay, it's just a streamlined formula for what we were doing by hand. Okay. Questions? All right.